My name is Melissa Russell, and I am with Wallarm, and I'll be your host for today. I wanted to let you know we are going to be recording this session, and we will be providing the link to the recording afterwards. If you happen to be on the LinkedIn community, I will put a link into the comments section for where you can actually just put your name and email address into the Zoom so that we can capture your information and send you the recording afterwards. But for today, I'd like to go ahead and introduce our speakers. I am so thrilled to be joined by Frank Kim. He is a SANS Institute Fellow, as well as Security Advisor. And he is also joined by Stepan Ilyin, who is our co-founder here at Wallarm. So they will be presenting the 2022 Guide to API Security. And at this point, gentlemen, I'd like to turn it over to you.
Thank you, Melissa. Hey, Frank, good to see you here.
Hey, Stepan, good to see you. Thanks for having me.
Yeah, it's always a pleasure, always a pleasure. Let me just start sharing slides here and let me know if it works, because I tend to mess with it. Slideshow, can you see it?
Perfect, looks great.
Yeah, let's start then. So as Melissa said, the goal for today is to discuss the API security guide, right? Like how to get into the API security, how to get some practical first steps, something that you can learn today and introduce into your work and life, maybe right away after finishing this webinar. And I'm actually very happy to have Frank here, because what I like about your presentations, Frank, it's always super practical. You can learn something while listening to you, and in many cases you conduct these workshops, they are super practical. I'm personally a great fan when you can try things right away. So I'm very happy to have you here. So let's try to keep it that way today, and add a discussion and just ideas around different kind of aspects of the API security.
Hey, I appreciate the kind words, Stepan. That's so nice. I could I could just let you go on forever and ever, but we've got a lot of good stuff to cover today. So yeah,
exactly.
Yeah, let's just dive right in.
Exactly. What I want to start with is the API security checklist. This is something that we recently released as the white paper. So don't be afraid. It's not a vendor white paper where we would say a lot of good things about our product. It's not that thing. It's actually a checklist where we talk with a lot of product security managers, our application security engineers, while talking about what is the API security for them, what do you need to have in mind while working on the API security strategy, on the API security testing, on protecting your APIs in production, on protecting your APIs that are exposed, and maybe the APIs that are not even exposed. And what we came up with is this practical guide, which has multiple sections API views, injections, and so forth. It has a lot of links to the tools. Most of them are open source that you can try to use right away. And typically we wrote it for, most part of it is wrote for the security teams, but also for the engineers. So feel free to share it across the organizations. And I think everybody will benefit it. Either you're directly into the security team or you just develop an APIs. I think that would be super helpful for everyone to take a look. And this is, you can go to the wallarm.com and download it. It's just available there.
So, hey, sorry, Stepan, I was going to chime in and ask you here, when I was looking at the slides ahead of time, preparing for this session here, I had a natural question come up. And I also think probably a lot of the attendees here might have a similar question. So, hey, this is a great API security checklist. But hey, while there's a lot of great information in here, how would you compare it to some of the other guidance and best practices, other lists, API security lists that you see online? What's different about this API security checklist?
Yeah, that's a great question. So one of the things that everybody should start with probably is the API OWASP Top 10. And actually, frankly, OWASP Top 10, the standard one. Those are the two kind of fundamental things to start your journey into the application security and also to the API security. But what we found is actually it has a lot of valuable data and a good insights in the way how we can structure your understanding about multiple threats. But it's not enough when you want to work on the processes, when you want to work on the kind of day-to-day operations and day-to-day like incident response, day-to-day development. So we've been trying to make it more practical so that everybody can introduce those things into the everyday work. But those things are complementary. So we are not by any means trying to replace API or step 10 here or or anything like that. Those things are complementary, and I would encourage everybody to take a look at both of them. So like basically three of them, like OWASP step 10, API was step 10, API security checklist. And there's some other checklists available on the internet. Like it's always good to have like this all the resources available and try to find something that is really meaningful and also applicable to your own situation, because we all work in different companies, we all have different flavors of APIs, and frankly we all have different challenges. So it's good to have like multiple options. But yeah, I'm glad to say this is another option, and I believe that it's very, very helpful.
Yeah, I like how you framed that in terms of being, practical and actionable and, tactical in a sense, in terms of, hey, what are the things that actually need to get done versus a high level summary, whereas you need all of those. So yeah, that makes perfect sense.
Yeah, thank you. Let's start. And one of the ways we decided with Frank for this webinar is to structure this exactly the same way as the API security checklist is structured. So we'll have like a few sections. Like first, we will talk about the proper API security management, and then about the injection and everything else. But first, let's talk about the APIs, like why it is so important. And we don't want to spend a lot of time on this, but there is some interesting data that we just can't avoid, right? Because sometimes when we come to the and like Wallarm is the end-to-end API security solution. So like we know all about the APIs security, and typically we talk with the different kind of tech companies and traditional enterprises about their API security programs. So sometimes we still have this question, hey guys, why is this API security even a thing, right? Like we have apes, we have APIs, and why do you specifically talk about the API security? And what's interesting here is that we have a lot of data points that are not even prepared by ourselves. So one of them is this data from the ECMI, one of the largest CDN in the world, which is saying that 83% of all the web traffic, like imagine it, 83% of all the web traffic are API calls now. That just are a fascinating number. Like everything is shifting to the APIs. But there is also some other data points, like Gartner, for instance, is saying that 40% of the attack surface is now in the form of the APIs, not a traditional web user interfaces, for instance. So like there are a lot of other things on top of it. By the way, like what do you think about this? Like API security is a kind of dedicated space for the product security teams. Like, is it really a thing, or you think it's more or less the same? It's just like a different flavor, right?
Yeah, great question. I'm probably dating myself here a little bit, but when I worked as a developer and engineer for many years and had to develop, write, and create and work with many different APIs. And in ancient times, a lot of them were SOAP-based API calls. And it was, in retrospect, of course, yes, it was still widely used today, but it was a kind of a hassle to work with those. And on the, if you guys think back to the prior slide, just one slide ago, in the fine print there, it had mentioned kind of the different types of APIs, right? Of course, SOAP, REST, now GraphQL, WebSocket enabled, and so on. And yeah, there really has been this shift, right, in terms of kind of traditional web application, heavyweight web application development to what we see now in terms of these cloud-enabled services, quote unquote, cloud-native approach that APIs underlying all of that. And so now we as application security professionals, product security teams, yeah, we've got to understand this crazy world of APIs. It's just a mass jumble in a lot of organizations that I see here, which I think ties directly into the very first checklist best practice, Stepan, on the next slide, right?
Correct. Do you want to talk more about it?
Yeah, and so this one here, there's a best practices. Stepan mentioned kind of, hey, there's lots of other frameworks out there. One of those frameworks is the CIS Center for Internet Security Controls. Now, that's not API specific, but controls number 1 and 2 are all about your inventory of your enterprise assets and your software assets. And this is basically what we're saying here too, in terms of appropriate API management, appropriate asset discovery. And I've been in many situations, whether it's been with my own team in-house or as a consultant going into new organizations, trying to give them some advice, assess their environment, where they themselves don't even necessarily know what APIs they have. It was hard enough keeping track of, well, what applications does an organization have? Many dozens, scores, hundreds, thousands in some cases, but multiply that by some factor and you've got the number of APIs that are used within the organization. And Stepan, I'm going to ask you about this here in a minute, but if you could go to the next slide, the question then comes up, if you're trying to discover your APIs, you're trying to get a handle on what's going on, wanted to point out here just one example of a free open source tool that is you could potentially utilize in your environment called API Clarity. Now, this is a pretty cool tool because it doesn't require you to install anything. Basically, by running in your environment, it can detect, it can figure out what API communication, what API traffic is going on using multiple different traffic sources and construct an open API specification by simply observing that traffic in your environment. So there's tools that also take this type of approach. This is cool because it supports Istio and Kong and other modern technologies that are in use today. But this is just an example of how you might go ahead and start to wrap your arms around this. But Stepan, what about you? What have you seen in terms of other companies, organizations? How do they, where do they kind of fall flat, and how do they get better at this API discovery?
I must say API discovery is a big thing. And I'm glad we have this API Clarity as an open source tool. It's, by the way, maintained by the Cisco and some other maintainers. So it's great that there is a solution that you can just listen to this webinar and install right away. And the problem here is that when we talk with the companies, especially with the larger orgs, the question that I personally like is that, hey, do you know how many APIs do you have? Or more specific, how many API endpoints you have? And the company say, yeah, I think it's roughly 300. Every time we run the POC with that, the proof of concept, when we actually, with the Wallarm, can help to find and identify all the APIs, we inevitably will find that there is much more. Typically, I would say 15, 20% more. In some cases, 70% more API endpoints that are exposed that people actually realize, which is fascinating because there's every single API endpoint there. It can expose some kind of PII data. In many cases, it exposes some kind of data. And there is no single person in the company that actually aware of everything they have. And we all been thinking for years about what are the services are exposed, what ports are open. But now all of a sudden we have all these APIs. Some of them are managed with the API gateways or API management solutions. Some of them are not even managed. And this is fascinating to see how many data is exposed without anyone in the company actually realizing this thing. So that's why one of the things we have here on the list is that you need to have this API inventory. And yes, you can do this kind of by introducing some hygiene and be more strict into the processes and the documentation. But also we highly encourage you to use different kind of tools and solutions. Frank already mentioned this API Clarity, which is an open source tool. We as a company, we also have this API discovery module, which is super popular. It works the same way, we try to tap into the traffic sources by being deployed inline or being deployed out of band, and basically collect everything we can know about the APIs that you have in production. So everything is conducted locally in your own environment, but as a result of it, you will have a full list of all the APIs, all the API endpoints, data about the parameters. And this will inevitably help you to find so-called shadow APIs, zombie APIs, because in many cases, just to give you an example of what we see many times, we run this API discovery for the customer, and they see, okay, we have this API for the checkout, for instance, and if you ask the question hey, do you guys know what is the actual version of this API? And you will get an answer, something there is a V4, but also we properly maintain V3. But all of a sudden, when you conduct this analysis on the real traffic, you will see that it's actually V2, a really old one, API version, which is not maintained, which is not bug fixed. It's still exposed, and the guys will try to investigate there would be some concern about the bad compatibility, and this is the reason why this API is still exposed. And we have tons of examples like that. So bottom line here is nobody really knows whether the API is exposed until we try to find everything based on the traffic. And I'm glad that there is some commercial tools, but also open source tools here.
Yeah, real quick, that's a great point about the zombie APIs, because if it's not running, like you said, it's unpatched, and that leads to exposure and potential vulnerability down the road. But yeah, and going back to that next slide that you just had turned to, before I start, I want to go ahead and pause here for a moment. I do see a couple questions in the chat window. Yes, this slide deck is going to be shared afterwards. Yes, there's going to be a recording that will be shared afterwards in case you need to step away for a work-related item. And I also want to encourage everybody here on the session to go ahead and please feel free to go ahead and chime in with a question in the Q&A window as well. We'll be looking at that to see if there's any pressing questions that you have as we go along. So what we were just talking about here was, well, hey, how do you abuse APIs potentially? Well, one way is to find an old, outdated, unmaintained API, an old version that could potentially allow an attacker to conduct some malicious activity. Well, what else? What is another bad thing that can result from API-related services that are exposed? Well, hey, it's lack of resources, lack of rate limiting, a potential denial of service type of situation. And so this is where we'd want to try to do things like implementing various rate limits, throttling certain communications requests, maybe from certain known bad IP addresses, potentially blocking traffic from certain geographical regions, or allowing certain known good IP address ranges. And one common way that mistake that I've seen people make is that they will publicly internet expose an API when it doesn't need to be whatsoever. It's really just a misconfiguration, a mistake that was made. Now, Mohammed has a question here. Hey, is this all about API security from threats or finding shadow APIs? Now, Stepan, I'll turn that question over to you. Hey, how do you think about that in terms of, hey, what are kind of malicious actors doing versus, another quote unquote malicious actor might be the internal threat actor, which could be, your internal teams as well, related to shadow IT. But yeah, how would you respond to that?
Yeah, that's a very good question. And I would say like shadow API is not a threat. It's it may be not exactly the same thing as an injection in your API code, but having shadow APIs, like something that you don't know, is also a risk for you. Think about this from the risk perspective, because at the end of the day, this is something that can lead to the data breach. We just need to keep in mind about all of those things. And to your point, Frank, about something that is exposed versus something that is just internal, what we see is a trend right now to protect not only those APIs that are exposed, but also internal microservices, internal APIs, and internal assets. I would say the milestone when we start to see this trend was the kind of the adoption of this zero trust model, when you actually need to protect all the internal assets as they would be exposed. And now for some of the largest companies we're working on, especially tech companies, they have this tendency to protect their internal assets with the same solution, with the same security rules, with the same policies actually, as if they would be exposed. They don't really have any difference in the way how they treat those APIs, regardless of whether they're exposed or not. And if you were asking me, is it something that everybody's doing? No, absolutely not. But if you take a look at some of the most innovative companies, we see this as a huge trend. Everybody's starting to protect their internal APIs now.
Well, I really like that you mentioned zero trust there, and we're going to talk a little bit later here about authentication and authorization. But zero trust, the couple core principles are that you're encrypting all traffic, and that you're authenticating all traffic as well. And by nature of having APIs, it kind of makes it a little easier, I would say, to do that, a little easier and a little harder, in the sense that now you've got discrete services that you can apply encryption and your authentication controls to. But going back to what we were talking about here, on the slide, in terms of denial of service, potential resource abuse, on the very next slide, Stepan, I just want to go ahead and mention, hey, how do you go about potentially mitigating some of these issues, implementing a control to protect against these type of situations? The good news is that, hey, whatever technology you might be using some sort of load balancer, an Nginx proxy, some sort of API gateway. You might even be using a cloud-based API gateway solution, whether it be from AWS, Azure. You might be doing your application load balancing using an ALB in AWS. The good news is that there are various similar configurations to do rate limiting, throttling, and so on to help mitigate various denial of service attacks. Now, I do see a couple other questions here. Muhammad has a follow-up question. Hey, how would you actually compare, and I'm going to turn this one over to you, Stepan, how would you compare WAFs, web application firewalls, that protect web applications to what we're talking about here in terms of API security?
Yeah, that's a good question that we need to answer like almost every day. There are a couple of things. First of all, WAFs, most of them at least, we're not supposed to protect, like we're not built to protect APIs, so they don't know like what is the gRPC, they don't know what is REST, they don't know what is SOAP, what is GraphQL. So they typically, in many cases, you would be surprised, a lot of vendors out there, they still can't even parse those data structures, which is a kind of ridiculous in 2022, but this is just a fact. From other hand, like a lot of those solutions are not ready for the API specific threats because in many cases, they are very different from the traditional apps and APIs. So that's another thing. API discovery, like this is not the thing that you will get with a WAF. Like this is a very specific API security thing. API security testing, identifying situations when your APIs are even vulnerable or can be exploited. Like it's another thing. So like WAF and a lot of WAF vendors are trying to catch up to introduce some kind of API security features, but it's still behind like against what's really happening. So like I would encourage you, and we, by the way, like as a platform, we provide this like next-gen WAF as a part of it because we consider that it's equally important to protect APIs, but also apps. So we provide a solution for both of those things. So hopefully I answered the question, but happy to chat more about that since we run all the demos all the time. And by the way, to your point about this rate limiting with the API gateways, load balancers, that's a great example that you actually probably have solutions that can run and help with the API abuse in your own organization. Just like go to the DevOps team, talk with them, go to the engineering team, talk about the different kind of rate limiting and throttling. In many cases, people would be aware of it. But at the very same time, for a lot of APIs, you would be surprised that you don't have any limits. So it's just make sure that you have this checkbox that you need to have limits for pretty much every API, because APIs, like it's so easy to abuse it. APIs is intended to be used by some kind of script, some kind of client. In many cases, it's something automated, or it can be even API to API communication. So like API is developed the way so it can be automated, like used by not a person, but some kind of software. So that's why it's super easy to abuse API, and protecting against those things like this is challenging. It's especially challenging, by the way, when you have it like deployed in the multiple environments. So in this case, you need to think how to do this throttling across all the regions and so forth, but that's a very different story. We have more questions here.
Yeah, and then you were just mentioning that APIs are not intended necessarily to be used by people, which is related to Yogesh's comment here, which I think that Yogesh, you might have typed in this comment and question before we got to this slide. Totally agree. Hey, that CAPTCHAs are not a good approach for mitigating and doing rate limiting for APIs. Exactly. And so, hey, what other measures can potentially be taken? Well, as we were just saying, hey, some of the things that you see here in terms of the configurations of existing solutions that you already have in-house can be one of the ways that you think about this. And then on the next slide, another thing that you could think about in terms of mitigation, well, is IP address-based blocking. And if you know that you don't do business in certain countries, for example, I've worked with organizations that didn't do business in let's say China, right? They were just a US-based business. Now the business might decide to go ahead and block on a country by country basis in those cases. However, I've always found that there were some outliers because one of your customers might be a large enterprise, a global company. They've got an office in China, and some people, some employees of that company might need to go and use your service. So yeah, this is something to watch out for. But Stepan, what else would you add anything to that?
Yeah, just keep in mind that these are data on the IP to country kind of matching. In many cases, they are not accurate. Like I would encourage you to go to buy something that is commercially maintained, like IP to location, MaxMine, but even if you're a subscriber for commercial feeds, this data is not always accurate. So be careful with that. Another thing that you can block is the data centers, because speaking of the API abuse, a lot of people would host their scripts, their kind of tooling somewhere in the data centers. And the best thing you can do probably, if you know that you probably wouldn't have customers from AWS or GCP, because those are the machines, those know that mobile phone in many cases. So you can just block the data centers and all the major providers like GCP, AWS, Azure, and others. They actually provide these feeds where you can automatically download all the subnets and add them to the blacklist and filter out all those things fairly quickly. And this is just an example of the Amazon, you can get this JSON feed with the subnets, so you would know what to block.
Yeah, and then here, another thing to consider in terms of kind of known, maybe bad related IP addresses, right? You might want to block some Tor exit nodes, maybe some, keep up with those lists as Stepan was mentioning in terms of figuring out, well, what are the most current known malicious IP addresses? But related to all of this, hey, Stepan, there's another question in here that, because, I know you operate at scale, I'm going to send it over your way, is that we've got a question. Hey, well, how do I figure out how to configure my throttling? Should it be 1,000? Should it be 10,000 requests per second? Kind of what's that range that you see is most effective?
There's no clear answer to that, frankly. I would be happy to give you a number. I just can't do that. But typically, I would say the best practice here is to take a look at the current usage. You need to have the data and visibility of how your APIs are used. And from this perspective, this observability about what kind of APIs you have, but secondly, what is the request rate there, how often this API is used, how this API is used by every single customer or user. That would be very helpful for you to understand the baseline that you need to set up for those APIs. And that would be probably one of the best solutions to go with. And some of the tools can help you to set those rate limits automatically, which is a good thing. But if you want a recommendation, what you can do right now is basically to set some kind of limit, maybe decrease it by half, see if it works or not. If it works, you can decrease it again and again. So that would be the general engineering recommendation, to set up the limits and timeouts, but be very careful with that. You don't want to break your application. And it's quite possible with this kind of things. Let me just give you a little bit of context about the Wallarm, because we also help to solve all those issues. So we help customers to analyze all the traffic and get the visibility of what is happening with all those APIs and apps. So think of it as full visibility to all the malicious traffic across your API portfolio. And we have this thing, we call it triggers, where it can basically say and set up different kind of rules. You can say, hey, if there are multiple requests with the malicious payloads inside, on this particular API or the application, so please consider this an attack and block it. Or you can say, hey, if there's any traffic coming from Tor network or from the data centers, and it has some kind of other particular thing that we consider malicious, please block it. So it's or another thing is just getting back to this idea of the rate limiting. You also can set up very smart rules on what do you consider to be the API views? And some of those things can be set up automatically, but you can also tune those rules automatically by saying, hey, if there is like more than 100 of the requests coming from this IP address with this session, I want to block it. And that is also possible with the Wallarm. So feel free to, if it's something that is you're interested in, feel free, and I will show you how you can use it in real life.
Great. Hey, now before I go on and talk about what's on this slide here, I did see another question come in, and I realized, hey, we could have talked about this at the very beginning to set the stage. But the question is, hey, what is the difference between an API, an application programming interface that is a REST-based or SOAP-based, GraphQL-based, and a microservice? Now, hey, I'm going to ask you, Stepan, in a second, kind of what your opinion of this is. But from my perspective, hey, when we say API or microservice in this case, they're basically the same thing. Microservice kind of by definition is a smaller piece of functionality, but technologically, right, they're all the same thing here in terms of the underlying technology itself. But Stepan, anything you would add to that?
No, totally agree. And I think one of the reasons why this person is asking this question is because I mentioned like we can protect internal APIs and internal microservices, which is in many cases like is the very same thing. However, sometimes like, we deal with the companies, they have some kind of third-party solution, which is working as an API. And in this case, it's not exactly a microservice. So that's why we prefer to separate all those things. But yeah, bottom line, it's all the same. Okay, switching the gears a little bit to the next section, which is injections.
Yeah, perfect. Hey, so I see that there's some questions that have also come up. We're going to get to those when we get to those associated slides. So just hang in there, everybody. But here with injection, it's actually related to one of the questions that looks like DF asked is, hey, how can you identify vulnerabilities via API testing, via pen testing, and so on? And earlier, Stepan had mentioned kind of the OWASP top 10, and the classic OWASP top 10 is your list of top application vulnerabilities. And then you've got the API-specific version of the top 10 as well. And you can see that there's a whole slew of different common vulnerabilities, injection being one of the top ones that you might also identify via testing, manual testing, pen testing, and so on. So DF, I don't know of a great way of identifying these other than, right, my personal favorite tool to use is a tool called Burp Suite for application and API related testing. There's a free version of this tool if you haven't used it before, and there's a paid for version of this tool, which is actually in the grand scheme of things, not that expensive, and it lets you easily identify things like the issues, test for the issues that we see here on the slide, and to see whether or not these protections are in place. One example here, before I turn it over to Stepan, is many years ago, I was doing a pen test of an application and corresponding APIs, and come to discover that the application, the web app itself, had a lot of good input validation, sanitization, but the underlying APIs that were being used didn't have any. And when talking to the API team, we said, hey, there's no input validation here. There could be things like injection that could occur. They said, well, so what? Right? We don't care because all of the data is coming from the web app. All the calls are coming from the web app. We know that they're doing the appropriate input validation. But what happens if somebody else calls that app in the future, right? This could potentially be a problem. So this is why, yeah, at DF, as you said, some of this manual testing is useful as well. But Stepan, anything else to add there?
Yeah, I think all those have very good points. One of the things sometimes people are asking us, hey, it's an API. Like an API, we get all those parameters. So like we already have it's like kind of data sanitation like for pretty much all the input, which is true. Like in a lot of API frameworks, like Flask, like a very popular framework for Python or many others, they actually do a great job on making sure that like it's less likely the developer can introduce injection. However, we still see injections, like different flavors of it all over the place in any APIs with the different protocols, with the different tech stack. And it still gives an access to the database for the attacker. So it's insanely popular right now. And we still see a lot of cases like that. So don't think that if you're like everything is based on the APIs, you don't have any injections. Unfortunately, it's not true. Another interesting example here is that a lot of companies consume data. using the API, like for instance, it's a partner API or the API of other services, and they fetch this data, assuming that this data is safe, that there are no malicious payload inside. And what do we saw? Like, it's also a very popular trend of the supply chain and supply chain attacks. It's kind of like the flavor of it. What do we see right now is like a lot of companies start to think, hey, we actually get this data over the API from our contractor, from our third-party service, but we don't really sanitize it. We don't really inspect this data, like with the API security solution or even WAF. Like, we don't know what's coming. We just blindly believe that it's safe and use it in our own systems. Like, and this is also a great area for the injection and everything else there. What I want to add here, and maybe we can show a few slides. So for the injections, you still can use solutions like WAF. However, a lot of WAFs don't really parse the API protocols. So like if you have a REST API and maybe you have some kind of something encoded in base 64, some kind of parameter, don't expect the WAF will parse this JSON and will decode this base 64 and find the injection there. This won't happen. Like, this would be just like the blind spot for it. So just a lot of WAFs don't really support the modern protocols. So be mindful. You need to know like what's your stack. If you're using WebSockets, using gRPC, if you're using GraphQL, and like all the other stack, it's less likely that the WAF will support it. So like be mindful. One of the recommendations we usually give is that you can also use these API firewall. Frank, do you want to cover this a little bit, or I can cover this?
Well, hey, I'll let you cover it here, but I'll just chime in here real quick. Related to what you were talking about, there are a couple of questions related to API related assessment. When I'm doing an assessment, manually to start, I like to get the, one of the best things to start with is just get the template, get the Swagger template that defines what is exposed in the API, and that's going to guide what you do. And related to what you were just saying, to kind of touch back and circle on another question here is, hey, well, should we perform vulnerability assessment and pen testing for both the API and the web application? Yeah, and short answer is yes, because exactly what Stepan said, hey, the web application might hide some of the issues in the underlying API, and other tools like a web application firewall might not know and understand that particular protocol, right? So just want to tie to loop back with those specific questions here, Stepan, before you go into this now.
No, that's actually a very good question. And in many cases, it's challenging. Like, there are a lot of tooling out there for the pen testing that can identify vulnerable services, for instance. Like there's the outdated version of the mail server or something, and you can like identify the version of it by fingerprinting, and then you can like really quickly find like what are the CVEs associated with this outdated version of the service. It's much more challenging to do with the APIs. Like, and this is one of the areas we're working on right now, actually, how, based on the traffic, identify that you're using this certain type of the APIs, and if you're using third-party software, how to identify what version of it, and how quickly find any associated vulnerabilities known for this API, so that you can do this like continuous assessment, like of what do you have, or maybe to conduct the assessment for you in the pen test. Like it is actually a challenging thing. And speaking of the pen testing, like one of the things that we like, everybody know Postman, right? So Postman is an amazing platform. Like a lot of people, they would publish the collections about like how to use their APIs. If you go there and like look for some specific APIs and like what the developers are uploading there, like you would be surprised like how many sensitive data can be in those collections, including username and passwords, which is just a completely new area. Like we've been for years looking for some kind of secrets by mistake uploaded to the Git or GitHub. But now there is like a new area like Postman collections, or there are some other like alternatives, like where the developers can just like upload something very sensitive. So that's to the point that the APIs are like, it's still a kind of application, but like you need to know like all these new flavors, because APIs are the new apps essentially. Like you can't avoid pen testing them and like not thinking about all those things. And getting back to the slides here. So one of the things that is super helpful to protect your APIs is what we call the positive security model, right? Because what's good about the API is that you probably in many cases have these specs, like This is the API endpoint. It has 3 parameters. 1 is optional, 2 are required. And this parameter A is expected to see some kind of number. You can use this actually to validate the user input. Like you can take the specs and basically match every request with the specs. If it's okay, like if it's matching, okay, this parameter is supposed to be integer and it's really integer, pass it to the backend, pass it to the API, it's properly saved. And if it has something else there, it's probably not supposed to go to the API backend. So like, funny enough, a lot of vendors out there, and like somebody asked about the question, like what is WAF versus API security kind of thing. So a lot of WAFs are rating this positive security model right now and claiming that this is API security. So like, yes, this is helpful to protect your APIs. From the other hand, we've been thinking, hey, this is a so basic thing. Like, do you really need to pay for this? Like, and what we ended up is open sourcing this tool. We call it Wallarm API Firewall. So like, it's a completely open source tool that like it's a very fast, high performance proxy that you can deploy for any microservice or maybe for the whole APIs that you have exposed, and basically apply this positive security model. So feel free to download it. Feel free to fork it and develop, like feel free to upload your new features. We're just encourage everybody to participate in this project because this is what everybody can just like try right now. And that would be a huge improvement to your API security, frankly, like free of charge, with full visibility of what is going on there. This is just like an example of how it works when you just like, there's a API firewall running as a Docker container. Somebody's passing the name into this API method. Like a name is supposed to be string. So like if it's okay, if it's name, like in this case, John, the API request, API call will reach out the API backend. If somebody is putting numbers like 31337 here, like this request will be blocked. And what's interesting is that we not only can apply these rules, a positive security model to the requests, we also can apply it to the response. So like in this situation when the API should respond in this particular part with a string and it has some digits, like it's probably some bad situation, you can block those things as well.
And hey, while you have that last slide up there about the showing the example protocol, it's related to a question that Christian has, a good question here in terms of, hey, do you recommend a specific protocol like REST that could be used to best protect the infrastructure? And yeah, to answer the question, it's, what you see here is some, JSON related communications, RESTful communications here. But Christian, to that point, it's not so much about picking like the best protocol. It's really from a security perspective, understanding how these protocols work. What is the difference between SOAP and REST and GraphQL communications and so on? As Stepan is pointing out, what's kind of normal communication, what is abnormal communication, and then using that knowledge to then identify anomalies and secure it appropriately.
That's right. And typically, like if you're a part of the security team, you need to deal with something that your engineering team decided to use, right? And for years, it was SOAP. Then like overwhelming, like most of the APIs nowadays, they are REST-based, which is a good thing. But now we also see this huge trend towards this GraphQL. And Gartner actually saying like in a few years, more than half of the APIs will probably be GraphQL-based. And we also see this trend towards the gRPC, like this binary protocol based on the open protobuf from Google, which is super important, like when you need to develop some kind of tools where the latency is a critical factor. So like we see more and more customers that are using gRPC like as a platform for their APIs. Okay, and thank you everyone for asking so many questions. We have a few that are not answered, but we kind of will try to answer all of them like when we have a specific section, because some of them are very, very much will be good fit for a few sections that we will have there. And we don't have a lot of time, frankly. It's only 15 minutes left, but we'll try to cover as much as we can today. Getting back to the WAFs, by the way, like I just want to spend a few words here. Yes, you can still use WAF, like, and in many cases it would be helpful to protect your APIs. Don't expect any parsing, any smart analysis of the protocols. So it will blindly apply the regular expression to the whole request. And if your malicious payload is not obfuscated, is not encoded, there's a good chance WAF can detect it. However, if it's a more complicated case, and I think I mentioned this already, there's a JSON for the REST API. And one of the fields is, for instance, like is encoded in base 64, like normally WAF wouldn't be able to detect this kind of thing. So what do we do in Wallarm? We call this deep API request inspection. This the idea here is that we don't ask our customers the API specs. We just like analyze the request, every request that we see. We automatically identify, okay, it's a gRPC based request, or it is a request that is coming to the REST backend. So we will apply the JSON parser. Then we will see the structure. We will see that some of those data is encoded into some kind of let's say base 64. So we will automatically unwrap everything until we have a full visibility to the full request, and we apply attack detection to every single of them. So like that's why we have like full visibility to the API request, and you don't even need to provide any specs for us, which is a big thing. You don't need to configure it; it just works from the very first minute you deploy the product. Next thing here. And this is a big one actually as well. So broken object level authorization. Okay, no, Wallarm, Frank, do you want to start with this?
Yeah, sure. This is related to a question that Jasjeet had in terms of broken authentication, authorization bypass. And yeah, definitely this is a big issue, right? This is a major area of concern, because what's going to happen if your authorization isn't working correctly? Hey, it mentions here randomly generated IDs. Well, if they're not randomly generated, if they are, let's say, at worst case sequential, it is very easy for an attacker to guess what that reference is to that ID, what is referred to as that direct object reference. And over the years, I've tested many broken applications that have had a bad ID that's easily guessable, and all of a sudden I get something for a cheaper price, or I get access to a different product, I get access to a different role. And these things that we would see normally in web applications, of course, have now, just to your question, carried over to APIs as well. So that authorization functionality, that authorization design, and looking at what those kind of IDs and those object references, those parameters should be, yeah, super, super important topic, huge area of concern here. Stepan, what would you add to that?
This is something that is, like, from one hand, it's new to API, there's broken object level authorization. From other hand, like, we knew about the IDORs for years, this insecure direct object reference. From one hand, it's a new thing, and maybe even more like actual for the APIs, but in reality, like, we saw this problems with the authorization, authentication, and everything for years. So this is something where you need to have a hygiene, like you need to use this authorization like in all functions. So what we see across the board is that there is a subset of the functions that actually use authorization, while some of them, for some mysterious reason, don't use it. And like you just like need to take a look at those things. But also like on the threat prevention level, like with the solutions, the API security, like in many cases, you can identify those things proactively when somebody's trying to, to abuse your APIs. And as Frank said, like to find this subsequent number, like again, like sending a whole bunch of the requests where they are not supposed to do, but also to identify the vulnerability. So like it's also possible to do. So can't really give you, unfortunately, like not for everything, I can give you the example of the open source tools can help, even though we try to include a lot of them here. But maybe there is some good solutions on that. Like feel free to share with us. We'll include those in the next version of the slides on the webinar, and the security checklist as well. There's just example of BOLA, but I think we can skip it. I think you gave a pretty good example of what the BOLA is actually. What do you think? Or we can talk a bit more about that.
Hey, we'll just mention real quick so you guys know what this slide is. Hey, two examples here. One is just simply showing that, hey, the shop name on online e-commerce platform might have different merchants selling on them. By simply changing the shop name or shop ID, hey, maybe you can access another shop's resources without authorization. Scenario 2 is exactly what we were just talking about, with that user ID value being some numeric guessable one. If it's easily guessable, you could potentially change your privileges to act as that particular ID, right? So that's, yeah, exactly what Stepan was saying in terms of kind of us mentioning this in passing on the other slide.
Those two examples, by the way, they are from the API OWASP top 10. As I mentioned at the very beginning, this is a must read for everyone. So like there's an example for every API OWASP top 10 threads. So like it's very good for understanding. And by the way, there's also like a couple of the open source projects which are like so-called like DEM vulnerable API. You know, they something that we used to use for years, which was called like DEM vulnerabilification. So there is a number of the DEM vulnerable APIs, which all has this kind of example of BOLA and everything else. Because I would encourage everyone to try and play with them, because this will just give you best knowledge of like what it is, like a real example, even though it's intentional, but you would be surprised that a lot of those things are unintentionally are actually in the code right now, and probably in the code that you're running in production. The segue to the next section actually is the broken user authentication. I think it's also related to the question that you just read, Frank, about the authorization and authentication.
Exactly. And, you know, Tamer asked a question about this earlier as well. So we were just talking about broken authorization. Well, what about broken authentication? Hey, that happens all the time as well. Tamer mentioned, hey, a lot of APIs that you see use basic authentication, even over SSL, over TLS. Hey, that's better than nothing. However, what's even better than that? You know, hey, you mentioned, Tamer, OAuth 2, which is what we mentioned here. OAuth using things like JWT, JOTS, JSON web tokens for the authentication process are both standard mechanisms that we see all the time now. And so from a security review perspective, you want to make sure that those things are in place and configured, used appropriately, and see where there may or may not be appropriate authentication that's necessarily in place here. Stepan, what else would you add to that, given our time here?
Yeah, that's a very important topic, by the way. So first of all, don't invent the wheel. You know, there are a lot of best practices, like what do you need to do about authentication? Try to find those best practices and apply it. And keep an eye on different kind of small details. Like for the JWT, it's an awesome thing to use. From other hand, like there are so many situations when you're using the weak key in JWT, so like don't do that. And that's just one of the examples when you're actually using the great technology, but you're using like you're also making some kind of silly mistake by using like weak keys, etc. and etc. Another thing is like, please don't return any sensitive information like passwords and tokens directly in the API responses. This is just like a bad practice. I already mentioned another case with the postman. So like educating developers what should go and what shouldn't go like to different kind of services, because you can find a lot of things like with the keys and tokens for the APIs that are hard-coded into the code, and the code is available like in Postman collections or GitHub. We see this all over the place. But you can also assess, and like you need to assess, like have kind of continuous assessment of your APIs and whether they have a good authentication or there is any problems on that. And we can do that like as a product, but you probably can do and develop your own tests. Like you don't need to have like, and in many cases, like it's security related, but it's also like the general QA process. You know, you just need to see if our authentication works or not, because like in many cases, I would say that this is an important part of your QA process, not even the security part of it. Let me see what's we have here. So like no slides on authentication. Is there anything you want to add here? Or maybe there would have more questions on this.
No, you know, I think, you know, on that next slide that you just went to, you know, I'm thinking, hey, given the time, we might go and end on the next slide here and then open it up and then take these remaining questions.
I think that's a good idea. I think that's a good idea, guys.
And so, you know, hey, Stepan just mentioned not returning authentication related credentials back in, let's say, your JSON response, of course, right? But what you also don't want to do is you don't want to return unnecessary extraneous data. Earlier in the slides, we saw an example of some JSON RESTful communications going back and forth. And I've seen too many instances where, hey, the developer just says, well, this is the data that I've got in the table or as a result of this query, or that is required to populate this object. Let's go ahead and just send all of the data back, which is not necessary, right? You want to try to limit the amount of records and the specific data for each particular request to avoid situations from a privacy perspective in terms of disclosing too much information. So, Stepan, what else would you add to this here before we turn it over to the to switch gears to the audience questions?
You would be surprised how many times we see this kind of issue. It's just like when the backend is returning everything, even if the front end doesn't really need it. Thinking that, okay, the front end wouldn't just show this. Yes, it's a sensitive field, but like it wouldn't be shown to the customer. Like obviously, this is not the way how it should be developed, and you just need an assessment. Like if you've never conducted this before, this is one of the first things I would try to do and see like what's your API actually exposing, what kind of data, and like is it really supposed to be exposed? Because across like many conversations with the customers, and the results of the pen tests and security audits, like we see this all the time, and this is just a very important thing to do. And we have a few action items here on the slide as well, like that you need just to follow. And I think Frank is right that we're running short of time. We have a lot of questions here. Let's just try to.
Hey, I'm going to rapid fire some of these questions to you, Stepan. But one real quick here. You asked on the prior slide, we mentioned MFA. How is that possible for APIs? Yeah, you're right. Hey, MFA is more for interactive type of situations, but this is also when you've got credentials that are used to grant access to an API. Hey, you might want to do them in an automated way, like the cloud services provide. You might want to do that in a time-limited way, things like that. Yes, but typically MFAs for users. But Stepan, I want to ask you here one other question. There's a question about latency with some of these API security related solutions. Earlier, you were talking about deep packet versus shallow inspection. What do people need to think about in terms of latency with any security solution here?
The thing is, there would be latency. So you need to choose the products that will add near zero latency. And this is where we invested a lot of time actually to make sure that these solutions can be used, for instance, in the e-commerce space. And those folks are paranoid about the latency because they directly affect the conversion rates, etc. So we made sure that even we conduct this deep API request inspection, even though we apply all the tag detection techniques, it's still near zero latency. But there would be some latency, like a few milliseconds. There would be something, and I think the person is specifically asking about this API firewall. So we ran the benchmarks, and it's faster than even the Nginx, which is, by the way, Nginx is super fast reverse proxy. So we actually developed this API firewall even faster than the Nginx itself. We have this question about, does Wallarm API firewall support end-to-end client over internet to service hosted in cloud with the HTTP2 gRPC calls? Yeah, the short answer is yes. This is one of the trendy use case for us to protect this gRPC based API. So we definitely can do that. And by the way, you don't even need to provide the protobuf specs for us. We will inspect it automatically. What else is left there?
I think we have time for maybe one more, maybe two more questions here. There's a question on API management. I think is related to the inventory we talked about at the very beginning. But hey, how would you summarize what when there's published APIs? Should you do it via some sort of API management solution? Any other best practices there?
Sorry, I lost you for a second. Can you repeat it, please?
Yeah, it's the question is, what is API management? Should you publish APIs via central API management solution?
Oh yeah, got it. So API management is basically when you're thinking about the software that helps you to manage APIs, to keep the inventory and to set up all the request rates. In many cases, API gateway, like open source Kong or Type, that would be a great example of the API management software. But there was also companies like MuleSoft or APG by Google, which also provide you this API management. And the idea here is actually to support you across the whole life cycle of the API. So actually, to that question, we have another question from the LinkedIn, because we broadcast there. So the question is do you need anything API discovery solutions like Wallarm or maybe this API Clarity in case if you already have the API management like APG in place? And that's a good question, because from one hand, you can see the inventory of your APIs at the API management level or maybe API gateway. From other hand, the most crucial part is what is not managed Like what are the APIs your developers actually exposed, and you don't even know about that. So like that's an important thing, because yes, you can have a fairly good understanding of what you have just looking into your API management or gateway, but there's a lot of things that can be exposed, and you even don't know about that. So that's one part of the discovery. And the question is also like, can it help to pinpoint authorized API usage? The question is yes, because when you analyze the traffic, you actually can see like the whole usage, like the real usage of your API. Another question, I try to make it quick: how to protect APIs against fuzzing. So like our API threat prevention, something like API firewall, API Wallarm API threat prevention, even WAF, like in many cases, it can help you against some kind of fuzzing. But that's an interesting question. The other interesting question is like how to conduct the API fuzzing, and there is a bunch of tools like Wrestler from Microsoft Research, for instance, you can use it. Is there anything else we didn't answer here in Zoom? I know that we are behind the schedule already.
Yeah, hey, I think, we're a little bit over time. So, I think, Stepan, we can, take these questions, separately. And, we might want to just go ahead and wrap it up right now. But hey, I had a lot of fun, in this discussion with you. I appreciate everybody's questions. The questions made it that much more interesting. So appreciate you guys sharing all of your questions. And yeah, hopefully you enjoyed it. And yeah, it was nice being here. Thanks for inviting me, Stepan.
Oh yeah, that was awesome. That was a lot of fun, Frank. And we covered a lot. We still have a lot of slides, but it's okay. That was our plan with Frank, to cover as much of the checklist as possible. So there is a huge portion of it which is still and is not covered. So what I encourage you guys is to go to wallarm.com and download this API security checklist, but also reach out to us. If you have any questions on the API security, if you have any challenges, if you're building up the plan for this 2022 year, what do you want to do in the API security testing, API security protection, happy to chat and to see what's your use cases. We're always available, so just reach out to us. And Frank, you're an awesome co-host, so it's always a pleasure to have you. So thanks again for coming.
Hey, thanks a lot. We'll see you next time.
See you. Thank you, guys.